Let's ask ourselves, where did our universe came from 14 billion years ago? A very intense energy, perhaps less than 1 millimeter, perhaps 100 microns, which is zero point 0.1 millimeters. Very condensed energy started to give forth things which we know today. What are these things? Energy first created time and distance, space, because in order to create mass you have to find space where this mass would move, and time, because this mass, to have velocity, it must have distance and time, because velocity is the change in distance with time. So first of all you have to create time. Before that there were no time. Billion and billion of years passed after space and time were created. Now we can say at that time, because now we have time. Before that we had no time. Here, quarks, the atom is made up of quarks, gluons, electrons. At that time, electrons appeared, quarks appeared, gluons appeared, but not yet formed or bound together to make atoms. Here, the high temperature, because of the intense energy. Energy means temperature, because where there is intense energy, there is high temperature. They were apart. It's something different from the plasma, because the plasma is the atom devoid from its electrons, or the nucleus separated from its electrons, but here it is quarks, simply quark, apart. When the energy density started to decrease, quarks got nearer and nearer to form atoms. First atom formed were the hydrogen atom, when the quarks were bound together to form a proton and an electron around it. This was the first thing in the universe, a hydrogen atom. These hydrogen atoms grouped together in nuclear what is like a hydrogen bomb, they formed the helium atom. The first thing that happened after the nucleus of energy, the 100 microns energy, very concentrated energy. The first thing the energy made was time and then space, length, because energy is E equals mass times square of length over square of time. So before creating mass, God created time and next space, because mass cannot move or matter cannot move unless there is space and there is time. In order to have speed or velocity, which is velocity is distance over time. In order to create mass, you have to create first time and then distance, space. Of course, the mass was created first in the form of quarks and energy grouped, packing them together to form a proton. But this was billion of years after the first creation, because now we can say after, because before that we cannot say before or after, because before time we have nothing. We could not say, we don't have tenses, past, present. Okay. Energy is, another form of energy is mass times specific heat times temperature. The more the energy, the more the temperature. Another form of energy, but not out of our interest today, is mass, current, electric current times, that's electric energy, times voltage times time. We usually use small t to stand for time and big T to stands for temperature. M times L square over T square. Okay, what is L over T? L over T is velocity, length over time, distance over time, that's velocity. Okay, then this means that energy equals mv square. Then actually for a moving body on our earth, the energy, his kinetic energy, he has E equals half mv square. So dimensionally, energy equal mass times square velocity, but for a moving body with a kinetic energy is kinetic energy equals half mv square. But if mass is transformed to energy, the mass itself disappeared to change to energy as in nuclear reaction. Einstein put the equation E equals m times c square. C square, where c is the velocity of light, but dimensionally energy is mass times square of the velocity. How is this? So this is for it's equal half, but for mass to change completely to energy, this is the equation. Then you could say they are interchangeable. Mass can change to energy and energy can change to mass. No. Only God used or dispensed energy to make mass, to make all the masses we see, the stars, the planets, the galaxies. We can change in nuclear reaction, in nuclear bombs, we can change mass to energy, but we cannot use energy, we can never change it to mass. One could. Now I just want to work with you a numerical example to show how much tremendous energy is generated when the smallest amount of matter is changed to energy. Let's see when simply 1 gram of energy of matter is changed to energy. Now here we have the equation, as you know, E equals m times c square, which is equal to m times c equals 3 times 10 to the power 8. So squaring it is 9 times 10 to the power 16. So let us suppose we have 1 gram is changed to energy. So let us substitute here. 1 gram equals 10 to the power minus 3 in the meter kilogram second system, because here energy is in joules. So m equals 10 to the power minus 3 kilograms, that's 1 gram, times 9 times 10 to the power 16 equals 9 times 10 to the power 13, that's 10 to the power minus 3, 10 to the power, okay, that's the amount of energy. Now let us think of something to feel it with our senses. Let's have, for example, 10,000 tons of steel. Steel has its specific heat. Steel, Cp steel equals 460 joules per kilogram per degree centigrade. You have to provide it with 640 joules to raise 1 kilogram 1 degree centigrade. So let us substitute a mass of 10,000 tons. Ton is 1,000 kilograms. That's 10,000 tons. That's mass times specific heat, which is 460, times delta T. We want to find when we change 1 gram to energy, how would it rise 10,000 tons of steel? How much the increase in temperature, delta T, equals the equivalent energy is, here we got it, 9 times 10 to the power 13. So delta T would be equal to, let's use the calculator please. So this is 10 times 10 to the power 3 times 10 to the power 3, that's 10 to the power 7. Okay. So let's use the calculator. We have 9 times 10, 9 times 10 to the power 13 over 460, over 460 times 10 to the power 7, 9 times 10 to the power 13 over 10 to the power 7 times 460 equals 19,656 delta T, 19,656 degrees centigrade or Kelvin. 1 gram change to energy can rise. So you see how much the rise in temperature of 10,000 tons of steel when 1 gram of matter changed to energy. It raised the temperature by 19,656 degrees centigrade. That's why, because the conversion constant from mass to energy is very huge. It's square the velocity of light. It's 9 times 10 to the power 16. So this leads to a question. How much energy did God dispense to make all this matter in the universe? To change how much energy made all the mass or the matter in our universe, our Earth, our solar system, the huge sun, the planets around it, millions of galaxies, like millions of solar systems in our Milky Way galaxy alone. How many galaxies in the universe? That's the visible matter. What about the dark matter, which is 5 times the visible matter? A question. Goodbye, dear audience.